If y squared plus x is x cubed minus y plus 6, we want to determine dy dx and d2y dx squared in terms of x and y, and evaluate each of these at the point 1, 2, where x is 1 and y is 2. So y squared plus x is equal to x cubed minus y plus 6, and we're differentiating with respect to x. We use the chain rule on y. It becomes 2y multiplied by the differential of the inside, which is dy dx. This is going to be 1. This is going to be 3x squared, and that's going to be dy dx, and of course the 6 disappears. So let's get everything with dy dx over to one side. So we've got 2y dy dx plus dy dx is equal to 3x squared, and bring the 1 over here. So dy dx into 2y plus 1 is equal to 3x squared minus 1. So dy dx is going to be 3x squared minus 1 over 2y plus 1. So let's leave that one there for a moment. Now, I want d2y dx squared. So I'm probably going to go from this line here. d2y dx squared is what we get when we differentiate dy dx with respect to x, when we differentiate dy dx again. So, if I differentiate again here, I've got a product. I've got u is dy dx, and I've got v is 2y plus 1. du dx is going to be d2y dx squared. dv dx is going to be 2 dy dx. So, this side here is going to become 2y plus 1 d2y dx squared plus 2 dy dx all squared, and the right hand side will just become 6x. So we have 2y plus 1 d2y dx squared is equal to 6x, take away 2 dy dx all squared. Well, that's 2, and we know dy dx is this, 3x squared minus 1 over 2y plus 1 all squared. So d2y dx squared is going to be 6x over 2y plus 1, take away twice, 3x squared minus 1 all squared over 2y plus 1 cubed. And let's leave that one there. We could tidy it, common denominator and all that sort of stuff, but let's not do that. So we want dy dx evaluated with x is 1 and y is 2. So that's going to be 3 take away 1, so that's 2 over 4 plus 1, which is 5, so that's 2/5. And then d2y dx squared evaluated with x is 1 and y is 2. So that's going to be 6 over 5. Take away twice. Now x is 1, so this is 3 take away 1, which is 2 squared. So that's 2 times 4 over 4 plus 1 is 5 cubed, which is 125. So 6 lots of 25, that's going to be 150. over 125. Take away 8 over 125. So that's going to give me 142 over 125. Let's see what we can get from the calculator here. So we've got impdiff just here, and we could put in our y squared, add x is equal to x cubed minus y plus 6. If we OK that, 3x squared minus 1 over 2y plus 1, which is what we got here. Now there was no feature where we could substitute in. We need to do that manually. The x is 1 and the y is 2. Now let's see if we can get it to give us the second derivative. So impdiff, and we'll put this in. So we'll put in the 3x squared minus 1, and we'll divide that by the 2y plus 1. And we'll see what happens. And it's produced for us a differential, which is in terms of y dashed. And we can see the 6x over 2y plus 1 bit here. And then over here we've got the 3x squared minus 1, 2y plus 1 all squared. Well, y dashed is this, so if we bring that in, we'll get 3x squared minus 1 squared, and the 2y plus 1 will be cubed on the bottom when we multiply this squared one by this. So this is the same result.